Great. I can see your screen, and whenever you guys are ready, go ahead.
Sounds good. All right. So hi all. Thank you for joining us. Like John mentioned, my name is Veronica, and I'm a digital manufacturing engineer for Northrop Grumman. And today we'll be presenting optical character recognition technology for the automation of production documentation. So I'm a digital manufacturing engineer under Northrop Grumman's Mantech group, and my role in Mantech's digital team is as a project lead specializing in AI and ML technology. And this is Marilyn, my co-presenter.
Hi, my name is Marilyn Arceo. A little background on me, I'm a principal database engineer. I just specialize in software and data engineering. A little background on our team, Mantech is primarily focused on research and development and bringing you next-gen initiatives to our sector, just to give you guys a little context.
We mostly focus on, we use the maturity risk level criteria to create a measurement scale for assessing manufacturing maturity and risk. So what Mantech focuses on, at least our group, is the levels 5 to 6, so upscaling from like a lab to a relevant environment, and then from a component level to an actual prototype, and upscaling that prototype into a production representing the system. So getting into our agenda,
Yeah, so we'll be going over, the problem that we're trying to address and the issues that we saw on the production floor. Just a few introductions to OCR, AIML, the approach that we use to execute this project, and a little bit of a technical review of this architecture and process.
Okay, so let me hide this. Yeah, so getting into our problem statement. So we are required to track and document hundreds of unique part labels from raw materials to the finished product within the manufacturing execution system. Like I said, these parts are subsystem parts. They require traceability, and their documentation is very sensitive. So we do document information such as like serial numbers, part numbers, but current practices are very outdated, we would say. Well, not outdated, but for example, within these unique part labels, we do also have different types of part labels that are required to be documented differently. But most of these current practices requiring documentation are mostly manual entry stuff. So they would just go into the MES system and manually type this information out, which results in a lot of like manual entry errors in MES. So our objective this year was to enhance the optical character recognition system scanner to process all parts throughout each cost center in our integrated assembly line. But our in-house solution will eliminate user error through manual entry, like we mentioned, and automate the process of grabbing part labels and attributes such as the serial number, like I also mentioned. So it'll increase traceability and accountability, and increase productivity and contribute to time savings. Okay. So introduction to OCR. So OCR is a technology that extracts data from printed or written text from an image or document into a readable form. So we can use that for data processing. The system is expected to be reliable in order to capture a variety of conditions. Like I mentioned, we do have hundreds and hundreds of these parts, and each part, no supplier has, I would say, a standard template for these image labels. So they have various different surface finishes. Some are engraved, some are stamped, some have a reflective surface, some have a matte surface. So our OCR really has to be reliable in that we have to be able to read all of those parts, right? Because like I mentioned, the person that we're delivering this product to does require us to have a certain accuracy, right? It wouldn't make sense for us to develop something and then have it be less accurate than the manual entries that are being inputted right now. But as far as OCR leveraging pre-processing techniques, Marilyn can speak more to that.
Yeah, we have to set up the algorithm and the, and the OCR technology for success. So, think of a Sudoku solver app. When, you're taking a picture of the puzzle to solve, sometimes we can't get that perfect image, especially if we're working on paper and not on our apps on our phone. So you might have the edges of paper coming up, that, it warps the puzzle, there's different lighting situations. And so, with the pre-processing techniques, such as like image skewing, correction, warping, we can fix some of those things that set up the OCR technology for success. And when we're leveraging this technology, we have to think about all the things we have to do to ensure we're setting it up for success, but also not compromise the clarity of the image. So, we can do noise reduction, we can do, image binarization, adaptive thresholding, contrast, sharpness, blurring, smoothing, but we also have to maintain the quality and the clarity of the image to make sure that we are getting, a good accuracy and a good, end product, and we are able to extract those, serial numbers or part numbers.
So introduction to artificial intelligence and machine learning in OCR. The OCR tool does lack the ability to understand the extracted text beyond, like it's just extracting it. So we do require a system to process that information that it's taking out and derive structures from it. So machine learning is used during the pre-processing phases, so the system can handle more intricate data. So AI is used for machine learning to diminish some of the system's limitations.
Yeah, and as a team developed this technology, we understood that a trained machine learning model was very valuable. But in order to achieve that, we had to do a lot of foundational work. There was an initial effort to gather images and, create that foundational data set that had various images and entity recognition models. And, building out that foundation led us to use that, incoming new data that we were getting to train and model and let itself learn.
Okay, so as far as the approach that we took with this project, we did start with requirements, and then we moved on to optimizing the user interface and user experience, and then optimizing machine learning. But as far as requirements, the first thing we did was identify devices being used for this application. Since it is an image processing, and that's heavily involved, we do need to have hardware that's capable of taking a clear image. So after we did that, we did develop a solution for the OCR tool, and we'll get a little bit more into the actual architecture of the program in a bit. And we became familiar with the performance for the off-the-shelf tool. And then after we did that, we investigated adequate computational power needed, like servers or GPUs. But yeah, once that was completed, we did, like I mentioned, move on to optimization of the user interface and experience. So since this web app is going to be hosted on a mobile site, it's for technicians on the floor. So they're on the go. They don't have time to, go into like their current processes. They have to go in to their desktop, walk all the way to their desktop, plug stuff in, log in, do all of this stuff. But we wanted to make it mobile for them. So we had to research mobile-friendly sites and UI UX designs, and add user prompts and mini guide tooltips to enhance user experience. Like I said, it's very fast-paced in the manufacturing environment. These technicians don't really have a lot of time, to sit down and learn the program. Obviously, we're developing it, so we know how it works and like know its kinks and stuff, like how to take the picture, all of this stuff. But we did add stuff to facilitate the experience for them. But once we completed that, we moved on to the final phase, which was optimizing machine learning models for additional cost centers. So that involved curating the data set and gathering all images and examples of all of these part labels on the floor, and then creating processes for updating machine learning models and scoring. So once we did that, we characterized the accuracy improvement from training on the new data set, and then tested and validated the solution for all of the remaining cost centers.
And to just go over the architecture, so we have a single web application. It's server hosted, it's on the cloud. And from there, you would capture the image of the part labels. So, if they're using, a mobile device, a tablet, or whatever it is, they'll use that method. And And once they click, upload and submit, right? It hands off to the web service, and we use a REST API. And after that, we use an off-the-shelf Python library called PyOCR, and that analyzes the images. And then we have Python code that collects all the analyzed data, and then once it extracts all the data out of the image, and after it does all that pre-processing and gets to that point, we return the label attributes such as like the serial number, the part number to the user, and that goes back onto the web application. We have a mock-up in the next slide, but we'll go over it. But the user verifies, submits the data, and once we submit the data, it stores that image on the server. We really did want that traceability and accountability, so we wanted to store that data, and we use the SOAP web service to put that information back into our manufacturing execution system. And if we look at the mock-up to the next slide, this is just like a really just a mock-up of what it could be, right? So, have like you said, we were focusing on UI, UX, trying to make it a little bit like user-friendly and very intuitive. So, we track the user ID, and then you have the part number and that serial number. So once that technician takes that image, they upload that image and it returns that data back into that form that they saw previously. And they're able to see the image that they just took. Once they verify everything, they can click submit, and then that will store all that information and take it back into storing that image on the server, and then submitting it into our MES system, and then we get that validation that, hey, this has been submitted successfully. But that kind of just concludes our technical review and our presentation. So if anyone has any questions.
Awesome. Thank you, Veronica and Marilyn. Yes, so if anyone has any questions, please feel free to write them on the question tab that we can address them.
I have a question. So as you were going through this, you were mentioning the importance of ensuring that the readers correctly identified the images so that your data was passing your quality checks. I was wondering if you could tell us a little bit more about what quality checks you had in place, and if you had any like QIF or standards for quality that you used to facilitate that, and kind of what your journey was for the types of quality passes and fails you saw as you matured this process.
Okay, so well, the current process, well, I'll just start by describing the current process, right? So these technicians are documenting the parts as they're being installed on the floor. So they're installing the part, but then they have to go back to their desk as they're installing, like I mentioned before, and type in all of this information. So usually, if they forget, they just write it down like on a piece of paper or something, and then manually type in the information on MES. And then QA does, our quality engineers do have to come down to the floor and take an image of this part to ensure that it is the correct part. So they take an image of the part after the technician takes down the data from it, and then they verify that, like, oh, the serial number is correct, oh, the part number is correct, they have the correct dash code. And then they have to basically just buy off the part and make sure it's correct. But most of the time, right now, what they're using to take pictures with is like very old school. It's like just a digital camera with an SD card. So the image quality, needless to say, is not the best, right? We have done, I guess, checks to see what kind of, what work is being done, and most of the time, the image is very blurry. You can't really tell like the characters on there. So it's very it's not that great, right? But one of the things that we're providing is, like I said, the technician will do this work all on their own, right? So they take the part, it'll be a mobile device. They take the part as the picture of the part as they're installing it. And that picture is also submitted to MES, right? So we have an image of like where the part was installed, what part exactly it is, because sometimes if something goes wrong, like a part is defective or something, they change it out, and then sometimes they forget to actually update the information on MES, right? Further down the line, maybe like in inspections or whatever it is. So that's something that configuration management has liked about our project. That we have that traceability. Yeah, but once, like I said, they do all this work on their own, but once the part is installed, QA still has to come down to verify that the picture that they took is part of the part, is a part that they've installed. So I hope I didn't talk too much in circles, but if I didn't answer something, you can go ahead.
No, you totally answered my question, but just to recap to make sure that I understood, essentially you have it built into your process that they take a picture and that's stored in your MES system, and it's a part of your quality checks for each installation. Is that correct?
Yeah, each part has to go through a quality check. Each part has to be bought off every single time it's documented like that.
Okay, perfect. Thank you so much.
Awesome. Okay, here's another question. What has been the acceptance rate on the shop floor with shop floor users? As in, how receptive have they been?
Oh, they love it. They really, really do like it. Like I said before, everybody on the floor is super busy all the time. They don't have time for anything. Like we've gone down there for testing and stuff, and it's always like go, go, go. So like I said, there's a lot of more than the technicians liking this, configuration management and production managers love this, because going in and fixing the mistake or the error on there, the manual entry error takes a really, really long time. So yeah, they're very receptive. But apart from that, so we have developed other functionalities. I think the strength in the application lies in its use cases, right? Because it's not like we're tailoring this. Well, we are tailoring specifically for the program that we're integrating it for, but this application can also be tweaked to fit other use cases. For example, like during like kitting stages or situations like that. But yeah, they love it.
Okay, great. We got one more question here. How long did you take to build this tool?
Well, last year it was in development, but like I said, Mantech focuses more on lower maturity risk levels. So it was only developed to like a proof of concept. This year is the year that we really like, for example, last year we didn't have any of like the AI or machine learning integrated in there, and we hadn't curated. We had a very, very small data set. Like I said, there's hundreds of parts that we have to trace, but there's this year, I think we started in February, that we started development in February for this, and then we had integrated, I think, machine learning a couple of months later, and right now we're just focusing on improving accuracy and processing time. So I would say proof of concept, maybe a couple of months, and from last year, and then this year until now. It's actually being implemented in production soon. So.
Okay, great, awesome. I have one question. Where do you see this technology going next?
Like I said, I think the strength lies in its use case. It's just getting people to, or maybe other management to be more receptive of their technology. For like I mentioned, right now these parts are being traced on the floor, right? But ideally, we would go further up the line, all the way to kitting. So you get rid of that work statement for the technicians altogether, and it's more time savings or cost savings. And then we also know, for example, like our goods movement, they also require tracking, not for parts like these, but for other parts like shipments they get in and like forms for receiving. So I think this technology would be very useful for them. I think their current processes as well are very outdated. I know it involves like tons and tons of paper, so we can get rid of that. Yeah, pretty much it.